Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Aaron Syme, founder and CEO of WebRTC.Ventures. WebRTC.Ventures is a custom design and development agency focused on building live video applications. We're here to help you take your application live. You can learn more about us at WebRTC.Ventures. Before we get started with our guest, though, we have some breaking news. Let's go to our CTO, Alberto Gonzalez, for a special report from Italy. Buongiorno, Alberto. Thanks for joining us today.
Thank you, Aaron. Yeah, nice to see you. Buongiorno.
Neither of us actually speaks Italian, but we're starting with a little Italian because you're in Napoli, right? In Naples right now at the Janus conference. How's it been? Is Lorenzo treating you well?
Yeah, he has been treating me very well. Actually, yesterday night, took us out to a very nice venue in front of the sea, and we had a chance to speak with like all the colleagues in the industry. So really nice.
Fantastic. Well, I'm definitely jealous. But tell us quickly about your talk at Janus conference. What did you discuss? And I assume we'll have a blog post up on WebRTC.Ventures soon with more complete information. But give us a quick description.
Yeah. So I presented a talk about integrating WebRTC apps with large language models and large action models, which is like an additional spin to large language models. And it was my first experience with large action models, and I got to play around with it. It was pretty interesting. I got some also good questions about how we could improve the performance, and how today is actually a bit challenging to do still, but it's early days.
Yeah, absolutely. Early days in a lot of this, but that's what makes these conferences fun. It's a chance to talk about some innovative ideas and get feedback from others. And I'm looking forward to seeing that blog post myself on our site and learning more from you. So what's something else that you've learned or an observation from being at Janus conference?
So, well, I saw the first day, a lot of people talk more about like scalability and monitoring and things like that, which are very important in WebRTC. Second day has been like today, has been more about AI, actually. Not surprised there, I guess. And we have been hearing about extracting media from Janus. Basically, that's where we use AI. We want to use that data that is happening in the video call or in whatever type of communication we have. So how people is doing that, planning to do that, how they are performing these operations in real time, and also scaling those solutions that are AI related. So yeah, that's, to me, I think that's overall like a short summary of what we have been hearing about.
Fantastic. Thank you. Yeah, thanks for sharing that. I'm sure we'll get some more observations from you as well up on our blog at WebRTC.Ventures. And I'm sure Lorenzo JanusCon will be posting a lot of information after the conference too. So we're all looking forward to that. Thanks for being there. And I hope you get to have a limoncello. Is that the drink, I believe?
Yeah. Well,
so
that's one
for me. One of them, yes. Yeah. Well, whatever you and the other attendees are raising the glass to tonight, have one for me and enjoy the rest of your time in Italy. Thanks a lot, Alberto.
Thank you. Yep. See you.
All right. We're back live now. Thanks for joining us live today on YouTube, LinkedIn, and Twitch. And welcome also to any of you watching a replay of today's event. For those of you with us live, You can ask questions throughout the stream by leaving a comment in whichever platform you're viewing this. And make sure you stick around for the end of today's episode, where we'll have a regular industry analysis segment with Sahi Levent Levi. For today's episode, I'm joined by Jim Rand and James Meyer from Cinervos to discuss advanced audio processing and WebRTC. Thanks a lot for joining me, guys. Let me tell our viewers a little bit about you. Jim Rand is founder and CEO at Cinervos and a two-time participant of TechStars in 2016 and 2022. With a background in engineering and an MBA in finance and entrepreneurship, Jim has a wide range of experience with everything from voice technology to private equity. Thanks for joining me today, Jim.
Thanks for having me.
And James Meyer is CTO at Cinervos and no stranger to audio innovation under the moniker Ghetto Cyborg. Meyer pioneered technology that made him the world's first cyborg DJ using an embedded system and head-mounted display, which was first displayed at an art party in 2003 and has made him a fixture at electronic music conferences worldwide. In addition to his work at Cinervos, he is also producer for Toronto's electronic underground music scene. So looking forward to hearing some beats today in our demos. Thanks for joining me, James.
Thanks for having us. Looking forward to this.
All right. Well, thank you both for being here. And let's start with a little bit of background. Maybe start with you, Jim. Tell us about the work that you all do.
Yeah, so it's primarily audio software related, lots of real-time communications in there. But I think to understand where we're at now, if we kind of go back to where we started when we went through TechStars in 2016, that really led to where we're at today, which is sort of a split between the consulting business and a product business where we've got our SDK for building audio software. So yeah, I can start with a little bit of a history there, maybe.
Yeah, so, absolutely.
Yeah, in 2016, when we went into TechStars, at the time we had been focused on building this sort of audio social network. People would describe it back to us as like an audio Slack. So you can imagine that you're able to publish to sort of one audio channel at a time, but be subscribed to multiple. And so if, a person or a group that I was subscribed to, like the stand-ups group or an engineering channel, somebody started talking in there, I would just sort of directly hear it in my headphones or through my laptop. And to sort of, you'd get this like really spontaneous intermittent conversation or like tapping somebody on the shoulder. And to make it super quick to sort of make yourself available or not, we had these voice commands so I could switch on and switch off. Or if somebody started talking to me, I could just say respond. And then I would start publishing back to the group that started talking to me. Or I could say, hey, switchboard, talk to James. And it would know who James is in my contact list and start publishing to him. So the whole idea being that it would feel like you're together in the same room and getting this sort of spontaneous intermittent conversation. And within a channel, there were all these other cool audio features, like if we wanted to listen to music together and stay in a channel for like an hour and just sort of chat in between, I could be listening to music. We'd have a voice activity detector that would duck the music when somebody would speak and it ramp back up smoothly when you'd stop speaking. So long story short, there were a lot of audio components into building that product. Somewhere around end of 2018, start of 2019, we realized like this really belongs inside of Slack and inside of other products rather than being its own sort of standalone product. And so we ended up pivoting toward an SDK, took a lot of the technologies that we had built in building the Switchboard app and went the SDK route. And to finance that transition, we started a consulting business where we've since been working on a whole lot of audio software development projects, many of which include, WebRTC or communication, real-time communication.
Awesome. Yeah, and we're gonna see a demo of the Switchboard SDK later, so I'm looking forward to that. But yeah, appreciate that background. Before we talk a little bit more about your work, I want to ask you to define that term audio ducking for us, because I think it's one thing you all are known for, and it's an important concept in a lot of applications where we're doing something more than just a meeting tool, right? And I think that's what's interesting about this conversation today is that a lot of when people talk about WebRTC, we're often talking about some variant of a meeting tool, but as the most common use case. But there's a lot of other things, and audio processing around those other use cases is really interesting. So define audio ducking for us and talk a little bit about the use case for that.
James, if you want to take the technical side of that, I can jump back in with some of the use cases at the end.
Sure. Well, so audio ducking is a tool, that audio engineers are very familiar with. Basically you have a key input, and a main out input, which is, probably playing music. So whenever there's signal on the key input, the music will turn down. So it basically makes space, inside of maybe that music to signal for something else. A lot of disco would use ducking, to really bring the bass drum forward. But it turns out that it's also very helpful for, understandability and communication when you're putting content and human voice together. So what we like to do is we like to duck the music keyed against the human voice. So we're listening to music, we're hanging out. It's just a very kind of third space kind of experience. When I start talking, the music comes down a little, and that makes my voice a lot more understandable.
Yeah. So if you're talking about listen parties or watch parties where you might be watching TV or a movie together, playing certain games together, there's this sort of other audio source that's you're otherwise going to have masked against the voice over IP signal. Ducking helps that. And you can do, simple ducking. We've done it within, a fixed frequency band. We've done it in sort of 3 dimensions where you just reposition the music or whatever versus the voice and position it in 3D or position different people in different positions. So there's a lot that you can do with it, but ducking in general is just sort of reducing the volume of the media signal when somebody's speaking, for the most part.
Excellent. Yeah, thank you. Yeah, appreciate that. Let's talk a little bit more about the division of your work. You mentioned that some of your work involves WebRTC, other cases, maybe you're doing things outside of web and mobile applications, hardware optimization, perhaps. I know you can't talk about a lot of your clients by name or the details there, but give us a little more a sense of the range of your work and which parts of it overlap with WebRTC in particular.
Yeah, it runs the gamut. If it's audio, there's a good chance we've, worked on, 20 plus projects, all that have audio in there somewhere. Platform wise, iOS, Android, Mac, Windows, web, down to embedded. So, embedding for headphones, high level, you can imagine trying to take an ML model and optimize it for specific, very constrained hardware. So that's in our domain as well. As far as where does WebRTC fit in, it's probably half the projects or something like that have a communication component where it's like, hey, it's a voice or a video chat coming together with music or a game or a watch party or some other media source. And there's sort of more complex audio pipelines that need to be built into that WebRTC application. Or it might just be, I don't know, a karaoke app where we want to have an auto tune or a voice changer, and then it's streaming live to an audience or something like that. So a lot of social apps, a lot of sort of fun, voice communication coming together with something else type of applications.
Excellent. So in a moment, I want to talk a little bit about, let's start talking about some traditional audio processing use cases, and we'll move on to some more unique ones. But first, I want to remind our viewers, you are welcome to ask a question of us anytime by just posting a comment, whatever platform you're viewing this, YouTube, LinkedIn, Twitch. And we do have a little comment here I'm gonna bring up, if you'll indulge me. Malaka complimenting Alberto and his update from Janice, and then asking us wishing we'd make a little more content in Spanish. So, perdón, Malaka, yo no hablo muy bien, pero intentaremos hacer más contento en el futuro en español para ustedes también. But if you stick around till the end of today's segment, you'll and we talk about the industry analysis with Sahi. We're going to talk a little bit about synthetic voices in there and why a synthetic AI would speak much better Spanish than I do. So apologies for everything I probably just butchered in making a live attempt there. But for anyone else with a question for Jim and James, more than welcome to put that in any point through the program there. So let's talk a little bit about some traditional audio processing use cases. Maybe the most common one we're used to speaking about in the WebRTC space is how like noise suppression, echo removal is handled now. Maybe talk a little bit about that from your perspective, either within the WebRTC context or in a broader context.
James, do you want to handle that one?
Yeah, absolutely. So some of the interesting new problems that we see specifically is because we do have that content piece that's inside of the apps that we're building and the audio pipelines that we're using. So a lot of WebRTC use cases, especially as it was becoming the standard, was focused on conferences and very voice centric. So the noise removal in there and the echo cancellation, is very good for those use cases. But when you start needing to put, high bandwidth, and, that's to say, music has, frequency information, up at 10 kilohertz and above, and voice is, all of the stuff that, humans need to understand what people are saying, is below that threshold. So the algorithms were able to be constrained in such a way to work very well inside of those conference spaces. So what we're looking to is the places, and it's great because WebRTC is open and it's open source, and we can get in there and make changes to the source in the applications that we deploy when we have that opportunity. And we can get in and either augment the noise suppression with some very cutting edge noise reduction models that we might be training ourselves, or that the customers are bringing us, in some formats like Onyx is, one of the ones that we're, excited about bringing support into our SDK for, and then other ML sort of implementations of like acoustic echo cancellation is some other stuff that we're looking very excitedly at.
Yeah, I think a lot of this is built in for that conferencing use case, as you talked about, and but doesn't apply well in other cases, which I think is a really interesting aspect of this. So talk a little bit about kind of the use cases where your clients want to do something more unique in web applications around maybe some of these traditional techniques in a web app, or maybe noise removal, or maybe other use cases like music.
Yeah,
Jim, do you want to discuss the switchboard main case?
yes. I mean, certainly going back to those sort of use cases where somebody's trying to have like a live listen party, you've got an echo canceller that if you're doing it in the browser, WebRTC has it included. Otherwise, if you're, building an iOS app, there's some sort of a default one that iOS provides. They never work well with music. Either the music is going to sound terrible, especially when you've got these cases where somebody's, some of the users will be on wired headphones, some will be Bluetooth, some will be using no headphones at all. The use cases fall apart. There's audio problems, and that's often when somebody will find us. And so you kind of have to get below all of the default assumptions that are made on each of the OSs, and Switchboard makes it a lot easier to do that. I mean, we've basically kind of developed a C++ audio engine, and then there's sort of OS specific libraries that handle all of that for you. And you can very quickly audition different, it might be an AI based noise suppression library, it might be a voice changer, it might be that auto tune. So there's a lot of different things that you can start to mix and match very, very easily when you're using Switchboard, and getting away from having to write lots of custom glue code and that sort of thing. So we're generally just doing our best to make it easy to take new use cases and mix and match sort of the state of the art, DSP libraries that are already out there, and put them together really easily.
Yeah, I think it's such an interesting space. I mean, in our work at WebRTC.Ventures, this was quite a long time ago now. We worked on an application that was intended for collaboration in the music space. And without going into all the details, it was challenging to think about doing anything in a truly live context with that, because you've got latency between participants, which is super important in working on music together, as well as, other issues and just sound quality and noise and echo removal. So, it ended up being more kind of recorded tracks that are then put together and stuff like that, which is maybe a bit of an easier use case, but with more advanced audio processing, I think it does open up a lot of interesting use cases and the ability to do more things in more of a real time and collaborative fashion. You mentioned a little like watch parties. I think once or twice in there, definitely a common use case that is different than a standard meeting tool, though certainly there's some overlap. The three of us may be watching a sporting event together, for example, as part of a watch party. Maybe, James, talk a little bit about kind of what are some of the interesting technical challenges and some of these other more unique audio processing use cases.
Yeah, the big interesting thing is how much larger the bandwidth is, and therefore, the mathematical computation space that you have to be dealing with, and the issue of the speaker information coming back into the microphone. It gets worse when that speaker information includes music, or includes the the hum of the crowd, which can also get kind of up there in volume, but also take away from what you're trying to understand then to send to the rest of the participants. So you do start to need some very some of the more cutting edge machine learning noise suppressions that are trained on these giant corpuses of human voice, and they really understand where to pick out a human speaking from a very high bandwidth piece of information, pull that out, and then we can get that on the wire. And then the communication is better achieved, and if we can get that lower latency enough, maybe we're celebrating the goals together,
right?
As we're watching those sports games occur.
Yeah, exactly. Yeah, I mean, you have these different streams that are being pulled together in the same application. You've got to worry about the latency of the sports feed itself, perhaps, right? They're usually on a broadcast delay, but then also making sure that you've got near zero latency between the participants. But and when they're watching that, how is it timed equally for them? So I think that's a really interesting use case with a lot of interesting technical challenges. I think you all have talked about like karaoke before, correct? Like, give me. I haven't done. I am not my karaoke singing would be much worse than my Spanish, but so I'm not a karaoke singer, but I think from a technical perspective, really interesting use case. Tell us a little bit about like something like that. What makes that different perhaps than a watch party?
Yeah. So they can occur in a couple different ways, but let's say it's a live streamed one. So you're singing live and there are people in a room, a virtual room, listening to you. I mean, we've done like live karaoke in a physical space type use cases as well. But, let's say we're talking about a virtual live stream karaoke use case. So there's music playing in, I'm going to be singing live through the application. Auto tune is almost always asked for, or something like it, some sort of voice changer, just so that if you are not a good singer, you feel more comfortable singing.
Right.
And that's happening in real time. And then there's going to be a stream through, I don't know, Amazon IVS or Agora or whatever other service is being used. But it's sort of a processing chain, so you on the publishing side, and we can actually see this in a demo later. I can show you a pipeline. But it'll pass through a few steps. It might include noise removal. It might include a compressor. It might include, that voice changer or a reverb effect or something like that. And then, the music, depending on where that's playing, that might be also sort of streaming live as well. So there's just a lot of different components that need to come together. And either you're writing a whole bunch of glue code and you're doing it once on iOS, and again, a different way on Android, or again, we've kind of developed something that makes it a lot easier to just sort of draw this in a no-code way in the browser, listen to it, and then sort of build it for each of the platforms.
Yeah, so that's a great segue. And by the way, John Tay says, great conversation. Thanks for this. Thank you for watching, John Tay. Appreciate it. But without further ado, let's get into a demo there. Which one of you would like to start?
I can do a real quick one, and then, depending on if there's any questions that come up, we can switch back and forth, I guess.
Perfect. So this is the Switchboard SDK.
Cool.
Tell us about it, Jim.
Yeah. So if we were starting a new project, this is basically a blank canvas and what it would look like. And you can sort of add these different nodes. So I go into the node editor. In this case, I'm just going to do something pretty simple. I'm just going to take a file player, take a guitar for the purposes of this demo. Just make sure that we're getting audio through. Everybody hearing that? Is everybody hearing that all right?
Yep, absolutely.
Sounds good.
Cool. So let's suppose, I mean, for the purpose of this demo, that's just a file playing a guitar on loop, but that could easily be a WebRTC node, and I could be playing my guitar live, and maybe I'm building a guitar effects app. So what effect might I add? Let's say I'm trying to add a flanger. We've got a really simple one that we built here. So maybe you can hear the difference when I switch this.
Yeah.
Or, there's another one, maybe you don't like that flanger. There's another third-party one from Superpowered, so I could kind of swap this out. Swap that one in. So I don't know how well you can hear the difference in effect there, but
yeah, really nice.
So this is all this is happening in real time. You're hearing it. You can play with the sliders and sort of get the effect that you want. And this, it's written as JSON that will ultimately be interpreted by our SDK. So if I want to build this for iOS, I just come in here. This would open up in another tab, but it'd show you how to integrate the iOS library and basically use the JSON that was generated in this graph. And now it's building the same thing in iOS or an Android or whatever platform that you're building for. And if it's green, it means like the graph that you've built here is going to work on these platforms. This one's embedded, so at least one of the nodes in here is not supported on embedded yet. But yeah, you can kind of at a quick glance see that you'll be able to output to those different platforms. So that's a really simple example starting from scratch, but we've also got a whole lot of sort of common graphs in here. So if I'm looking for one for WebRTC, this is an example where the top here, so we're starting with the microphone at the left. The top is basically the publishing from microphone into the WebRTC sync, which is Agora in this case. And then the bottom here is a WebRTC source. So I'm basically sending in this top part of the graph, and then I'm receiving audio from whoever is in that room in the bottom, and it's outputting to my headphones here. And so you can probably hear this. We've got a reverb effect applied. 1, 2.
Yep, definitely.
And now if I turn that off, the reverb is gone. Blah, blah. And now it's back. So, we've got, in this case, a noise filter followed by, this is more or less a pitch correction auto tune. This is very similar to a karaoke use case where I'm singing live into an Agora room. So there's the pitch correction followed by a compressor to narrow the dynamic range with that reverb effect. But yeah, you could apply sort of any number of effects. It could be a voice change or, sound like a celebrity AI model or whatever you want, really.
I love it. This is super cool. First of all, I want to say like the quality in that sounds so much better than, last time I tried, to play with an application in this space. So I think that's super cool what you're able to do there. The effects are really impressive. And so I appreciate the, showing the WebRTC specific part of that demo too. It highlights that if we wanted to have a remote karaoke application, and as you said, my singing voice is not awesome, so we could apply those filters on it. As you were playing with those filters, Jim, it also, one of the last ones there, maybe think of, you're like walking through a cave with that sort of echo and reverb in it. So if we were doing a gaming application, perhaps we're, playing with friends and you're able to have audio chat between each other, then to be able to also maybe make some effects on the audio as if based on the space you are in the game, right? Your characters are walking through a cave, so let's make it sound that way. Let's enhance that experience. All sorts of, maybe somebody's already done that, but that just popped right into my head. Free idea for anyone out there. But just lots of fun, really cool stuff that you could do with this. So this must be opening up a lot of really interesting use cases that you all get to work on.
For sure. And I mean, like on the gaming side, or metaverse spaces, you can imagine. So we've got like a virtual office sort of platform where, you can walk around, there's spatial audio, and, there's occlusion. So, if you're behind a window or, if I open the door to the room, it's going to change the acoustics. And so there's a lot that you can do. We've got a lot built into Switchboard, and we're running a lot of experiments on the side, both, in sort of iOS example apps that we build, as well as these sort of 3D environments and games, and connecting into a lot of the common. So in the gaming space, Vivox is a commonly used SDK for in-game voice chat. So it's a matter of starting with sort of what are the common audio libraries that other developers would use in each of these spaces, making sure that we make it easy to assemble audio graphs with those libraries.
Mm-hmm. Absolutely. Yeah. And I can't resist making a Max Headroom reference here for those old enough to remember. I heard some Max Headroom similar effects there in your voice also. So I can be Max Headroom in the metaverse, which would be fun. James, did some additional items you want to show us as well?
I mean, I don't necessarily need to go, to the tape, as it were, but one of the things that we are, putting together, presently is the ability to bring, sort of your own Onyx models, and have them operate inside of a graph, both in the editor that Jim was just showing you, but then also be able to more easily deploy those models into applications, using our SDK. So each of those were the effects and the sinks and the sources were all sort of classical DSP or obvious sort of WebRTC library function calls. We're also currently working on a node where we can bring in a model that's been trained to do something very specific on audio, drop that in, and then help facilitate getting that into applications in various developers needs. So somebody can do the training. That's a specific kind of workflow and tool chain. And then once you got the model, how do you get that into applications?
Yeah. It's an important point here is, some of the like effects you have built into the SDK can be used, but also the ability to integrate with external models and do your own processing. What sort of latency do those, either your effects or those sort of external services add? How do you manage that? And does that affect or restrict at all sort of use cases you would recommend people using?
So we definitely make sure that all of our classical DSP is as fast as possible and low latency as possible. So both sort of computational latency, but then also play through latency. The AI, obviously that's something that once you've got your stuff trained and you have a sense of what your networks look like, you're going to need to optimize for what latency, that model is adding. We're definitely seeing, and we are working with some low latency models, in the 16, 32, 8 milliseconds, when it's definitely been tuned very aggressively. Some of the processes that we're seeing, they're still north of 100 milliseconds that are doing some really, wild kind of magical things that, in some cases, physics defines how much
right.
How much latency is going to be there, just because we can't travel in time and the speed of light is so much.
What it is.
It is, but we're definitely, latency is very important for us because the ability to communicate with other humans is one of the main things that we want to make sure is baked in and utilizable on everything we do. So we care about latency. We make sure it's measured. We make sure it's something that's observable inside of our systems.
Right.
And then we take on, the models that we have a sense of, okay, we know where we can fix this and either minimize latency, process it, correctly, get our pipelines, performant in the way we need to, or, fix it upstream of it.
Yeah, and it depends as well, like whether you're running a model or that process like in the browser or sort of locally, as opposed to needing to go out to the cloud and come back. And then again, it depends on the application. Like if there's already network latency because it is a WebRTC based use case, having to go out to the cloud to do something is not as big a deal as if you're trying to, process something locally in real time. I could even, if you wanted to put my screen back up, I could show you a quick, let me just go back here. This is another example of one where, so this is another Agora example that I pulled up here where it's passing through. Let me just take this noise gate out. So this is actually using Pico Voice, which is a third-party speech to text. This is actually running in the browser. Let me just zoom in on this a little bit more here. So you can see it's transcribing in more or less real time, but you can also sort of observe the latency that's present in this case. But it's, it's pretty close.
Nice. Yeah, it's definitely an important thing to consider with the use case, right? If we're, doing processing that requires more than 100 milliseconds, for sure, it's going to be difficult to integrate that in with real-time conversations. But you're staying under that, then you can apply these in a more real-time scenario. So, yeah, all depends. As we always say, it depends on your use case. But cool that you have that that ability to kind of work within both. Starting to get to the end of our time here, I want to talk a little bit about a little more about AI and audio processing. There's certainly machine learning being used in things as relatively basic as noise suppression and echo removal, to then using more advanced techniques around some of these effects and stuff. How do you see AI being used in the future? Within your platform, or more broadly speaking?
There's a lot of individual nodes that will be AI based. So whether that's stem separation, where you might feed music in and feed different stems out, or you might strip vocals out for a karaoke app, to it might be generative music. It could be again just noise, echo suppression related stuff. Effects like voice changers. So a lot of different nodes, and we're experimenting with a lot of them right now. LLMs, you can imagine how you might be able to, include AI bots inside of your social applications and have one in your conversations and that sort of thing. So yeah, I think it's as far as we're concerned with Switchboard, it's in the nodes, as well as potentially we're going with sort of a no-code editor right now, but eventually you could imagine having an input that is like, hey, build me an app that does this. So I think the further out you look, the crazier it gets. But James, any?
Yeah, I mean, as Jim said, there's a couple of different sort of orthogonal approaches that we can be taking. One is having LLMs understand some of the context, of what that JSON is doing, what our editor that we were showing you can do, and assist you in putting together your audio pipelines, and then hopefully deploying, getting apps quicker, into production. And then at every kind of step, there's some interesting places where AI, will do great. There are places where it's probably overkill. Part of the stuff that we're really excited about is the different sort of stages at which you can be using it, in the cloud. If it's really heavy, high compute sort of, ML, really big matrices, a lot of computation that needs to happen. Can we get that up? Can we afford the latency? And then, can we get, what kind of models are we able to run, on mobile as it's getting the information from the network in time? And then, what kind of models are going to fit in the form factor of a Twee, an earbud, a headphone, or a speaker on the edge, to do those, sort of lower sized compute, workloads that, okay, we can get them there, and then it can be absolutely just immediate sort of feedback.
Yeah.
Which is what we want as humans. But then, when we have these trillion trillion parameter models, like they take a lot of juice to execute, but then there's some really neat stuff that comes out.
Yeah, absolutely. And speaking of neat stuff, as you know, we're having this conversation on May 15th, 2024. Yesterday was Google I/O 2024. And Jim, you mentioned generative music. That was one small segment within their larger presentation about all sorts of things, most of which were related to AI, of course. And the generative music was interesting. It showed a music AI sandbox demo that you can find online. There's an interview in that with Wyclef Jean and Mark Rebillet about the use of generative music in their work, and I thought it was really interesting. Wyclef talked about it speeding the creative process, and Mark talked about it kind of helping him fill in the gaps on music beats and stuff in his DJ work. So James, I ask you to put on your either virtually or in reality, if you have it right there, put on your cyborg DJ hat, and I'd love to hear your thoughts on kind of generative AI and music in general.
Yeah, like I'm definitely excited with AI as a tool, as another tool to put inside of the producer or the musician or the mastering engineers, toolbox to make the best art that they can. Using it inside of your workflow. I think there's a lot of interesting VST plugins, and digital audio workstations that are going to make new sounds. People were kind of afraid of the synthesizer, and MIDI, the musical instrument digital interface, that, it's going to get rid of musicians and players. I think we're seeing something like that. It's definitely, we've scaled up. We're at kind of 10x what synthesizers meant. But insofar as it being a great tool, yeah, I think that's the case. I don't know that anybody's re-listening to any of these songs that have been used in generative AI. My challenge is, if anybody's actually bookmarked and listened to one of these things 10 times, please let me know. I'm kind of using that as a ruler, is have we gotten far enough,
Right.
insofar as, are we able to use generative AI to generate music on a quality level, that it's doing it on its own.
Yeah.
That it's being done on its own. But in the meantime, it is a even more fertile landscape for the utilization by humans to create great art.
Yeah. To me, that's key. I think in most things around AI, and in all senses of it, it's about augmenting human capabilities and improving what we can do, making certain things more efficient and stuff. So yeah, I think it's, if it's able to kind of fill in the gaps, as Mark Rebillet said, to me, that's a pretty good metric for something being useful, but also still really contributing to and improving what is still and should be a human creative process.
Yep.
Excellent. Well, we're at the end of our time here, but really enjoyed the conversation with both of you. Thank you so much for being here. Do you have any closing remarks that you want to share with us, and how can people learn more about your work?
Oh, I think you just brought it up on the bottom of the screen. Keep your eye out for some changes on Synervos.com. I think we're going to be putting a sort of venture studio page on that site that's got a bunch of our sort of internal experiments that we're working on, and we're always looking for new partners to advance some of those projects. So if anything seems interesting, then we're pretty friendly to talk about it.
Definitely pretty friendly. I can confirm that, and appreciate you guys being here. And yeah, this is a really excellent toolkit for any of the developers watching this program to have, for a way that you can interface with some of these things, do some interesting audio processing and effects within your applications. So certainly encourage you to check it out at Synervos.com and switchboard.audio. Thanks again for joining me today, Jim and James. Really appreciate both of your time.
Thanks for having us.
Thank you so much for having us.
All right. Great. Well, thank you, all of us, for joining us. Remember to stick around. We are going to have Sahi joining us for an industry analysis segment in just a moment, where we will continue to discuss audio processing and machine learning in WebRTC. But first, let me remind you that this video is available in the WebRTC Ventures YouTube channel. It'll also be up on our blog at WebRTC.ventures. And our next episode of WebRTC Live will be on Tuesday, different date. We usually do these on Wednesdays, but it'll be Tuesday, June 18th, 12:30 p.m. Eastern US. Our guest will be Sean Dubois from the Pion Project, and we'll be talking about Pion and broadcasting, and always a great conversation with Sean. So definitely put that on your calendars. Check us out then. To find out more about upcoming episodes, follow us on social media at WebRTC Ventures on Twitch, LinkedIn, YouTube. Join our email list at WebRTC.ventures. So thanks everyone for joining us today. Let's make it live. Thanks for joining me today, Sahi. Let's talk about machine learning and audio processing. So start by sharing with us a few concepts people need to be aware of, how they're used, and who's responsible for continuing these innovations that we all depend on.
Okay, so let's start with what it exactly means to do machine learning in audio processing. And there are like a lot of different things that you can do. Let's start with the most obvious ones that everyone talks or does, which is noise suppression. I want to remove clapping sounds from the actual audio, sorry, which we're not going to do in this recording, I think, because there is
obviously, because I heard you.
Yep, exactly. But there are systems that do that. For example, Google Meet, I think Zoom as well, and you can decide to, enable it, disable it, put it into a certain level of sensitivity, and what noises do you cancel babies or not? Do you cancel dogs that are barking? Do you cancel your neighbor that usually decides to renovate his house whenever I do calls? So there is that. And it started somewhere in the beginning of the pandemic, and we still have it today with companies adding that in different ways. Then there are things like packet loss concealment. We've seen WaveNet from Google that does that for Google Duo, where they say, well, it looks across the packets that were received, and then we're going to estimate based on that what the packets that were lost should have been. But that's by listening to the audio itself, which is machine learning in nature. So I can do packet loss concealment with machine learning. I can also do things like forward error correction. How much to invest in forward error correction based on what happened in the past in the packet loss side. Okay, I can do it without that. I can do it with that. And today, when you see companies starting to think about and investing in when to use forward error correction, they're not trying to do it with rules, but they're trying to just throw machine learning at that, because that's what we do today when we develop. We stop thinking, we've got machine learning to do it for us. Good or bad, that's a different question. I think the two other areas that you see today is codec compression. Lyra is a machine learning based codec. At one point, it will come to WebRTC. Opus version 1.5 has a lot more machine learning than previous releases of Opus, which still had machine learning in them. And then you can also say, well, we can do echo cancellation with a bit more machine learning than we're doing now. And again, there are companies that do that. The other two things that you start seeing today, one of them is to change the voice. I want to sound like someone else. That's an option. Okay. And the other one would be almost the opposite. I want to have my voice signature and then use that. And I can play with that. I can decide, let's remove Tzachi's accent because we want him to speak English and not Hebrewish or whatever it is that I'm speaking with my own accent today. And I might want to do that and use text instead, or we might use that to improve the audio on the receiving side, for example. It's not packet loss concealment, it's not forward error correction. It's me sending text and you receiving my audio as it should be, or sending something akin to text. So you see all of these things that are taking place today in media processing, and I guess I'm the only one speaking, but I guess the answer it is that whatever you can do with an algorithm today in the media processing pipeline of audio, we're starting to see companies trying to replace to machine learning. Why? Because we can.
Well, you didn't hear me speaking for a moment there because I was doing traditional noise suppression. I went on mute while there was a noise in my building here. So that's the old manual way of noise suppression. And obviously in the old manual way of echo cancellation, I'm using as well with my headphones.
Mhm.
You obviously have more faith in the echo cancellation built in. But these techniques are interesting too, because there's different, I guess I would say, not really being a machine learning expert myself, but kind of different levels of the sophistication needed in them, right?
Yeah.
I mean, echo cancellation to a degree is looking for a repeating pattern and cutting off the repetitions of that, right? Packet loss concealment, a little more sophisticated because you're doing some synthetic generation of what those missing packets should look like based on the surrounding ones, right? And then, of course, changing the voice is interesting. We can use the web audio API to process it before using that stream, right? But that's going to add in latency and complexity. And then, you mentioned accents. I had a synthetic voice sample generated off of my voice once, and it was fascinating because when it spoke in English, it was pretty good. I could probably tell the difference. I'm not sure others could. But then they had it speak in Spanish, which was really impressive to me because while I do speak Spanish, I speak Spanish with a bit of a North American US accent, right? So hearing what a synthetic voice, how it would speak Spanish with a better accent, but still in my voice was really, I don't know if it was inspiring or humbling. I've got a little ways to go still.
Were you
right?
frustrated because of that?
No, I do okay. No, it was just kind of helping me know what the next level should be, at least according to the AI for me, right? But I think it was still cool because, if like a great application of things like that, right, is if I wanted to do a Spanish language version of WebRTC Live, for example, right? I could try to do that, but it's not going to be anywhere near as good as doing that with AI, right? So us being able to do that in recordings, and you've talked about seeing that at conferences in real time done as well, I believe, pretty cool stuff. But obviously different layers of the sophistication necessary to do that. Give us a quick idea of where, because these things can build on each other, right? There's some built-in echo cancellation in WebRTC, but others can use it as well. Yeah,
I want to talk about the echo canceller. You said that it's easy, but now let's complicate things.
Okay.
We do echo canceller. It's easy, but then there's this stupid thing that I was told that is called reverb. And reverb is when everything is glassed around you. And whatever audio is there vibrates from the walls or whatever in the room and gets into the microphone.
Right.
Okay? With or without video conferencing, with or without having something speak out at the same time. What if I want to remove reverb? So a few years back when I recorded my own courses, I had the audio, I sent it to someone on Upwork. He said, we can't remove the reverb. It's impossible. It's too much work. It's manual work. So I had to go and buy this nice microphone and go and record in studios instead because this has less reverb. I have no clue why, but it's condenser and whatever. I'm clueless about that. But today, if you want to remove reverb, there are algorithms, machine learning based, that can do that. So even if you think about things like, well, echo canceller is easy, once you take that on itself to the next level, you can start saying, well, now we can do better things if we're more intelligent in how we do that.
Right.
Okay.
Yeah. Easy should always be put in quotes. There's some video AI that we need. Whenever I say easy, finger quotes should appear on the screen automatically.
Yep.
So there are multiple layers of this between hardware, software, browsers, operating systems. That's a lot of different parties kind of responsible for this.
Yes, and the answer is no one is responsible besides you. Okay. And you can be either the application developer or it can be the end user. What do I mean? I can bring a better microphone. In the same way, I can install an application that would improve the audio and do noise suppression or whatever it is that I want. across all the applications that I have. We have such a thing called Crisp AI. You can go download, pay them, and you have that running across everything. I can edit as an SDK to an application, again, from Crisp AI or third party using open source into my application, and then it runs only in my application. I own that as a service provider, and I offer that as part of the solution. It might just be that it happens to be something that is available in my laptop or PC or phone to begin with. For example, echo cancellation with or without machine learning, okay? That comes from the CPU or GPU or whatever. Someone magically decided that this should be there. You see it a lot more today in video, where all of the CPU and GPU vendors are trying to talk about super resolution for YouTube and gaming. There would come a point where they would say the same for video conferencing because they can. And then scaling up something with machine learning, which is called super resolution, will happen to be something that is available in the CPU, and it's not something that I need to add as a developer. Other things end up inside the browser for us automatically. Opus has a bit of machine learning in it. We all enjoy that. We don't know that it's there, but it is. It selects which codec to use internally because Opus is actually two separate codecs, and it does that based on if it is hearing noise or speech. Noise for it is music, okay, in this case. So you have different places where you can do that, and I can also do it in the server. For example, NVIDIA Maxine is a server platform with software that does some of the things that I just discussed earlier on the server side. And now I need to send the data to the server in order to do that. I do it there, so there are privacy issues on one end. On the other end, I have it everywhere for whatever scenario that I want. Regardless of the device that is using it, do I have enough CPU there? Is it on the hardware of the chip of Intel or whatever? I couldn't care less. It just works for me. Okay, noise suppression for Google Meet, for example, at least in the past, I don't know now, they said that that happens on the server. They process that in the server and not in the client. So where exactly these things go, I don't know. It depends.
Yeah, and there's trade-offs between them. In the cloud adds latency, on the client adds processing power.
Yep.
There's a lot to consider here. So, as you said to me just before we started recording, there's no easy answers on this, and so we'll have to leave it there for today. But definitely important topics for any WebRTC application developer to look more into and not be fully dependent on what's provided to us. As you said, it is up to us as developers as well as the individual users of the applications. So thanks for sharing your insights with us as always, Sahi. To learn more about Sahi's work, you can check him out at bloggeek.me. And to learn more about future episodes of WebRTC Live and our work, check us out at WebRTC.ventures. Thanks a lot, Sahi.
Thank you, Aaron.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.ventures to learn more about our custom design and development services and to learn more about upcoming episodes of WebRTC Live.